last class, and I had to put on this caveat because I don't mean this like you guys don't know what you're talking about. My littlest daughter, who's in preschool right now, came home singing this song about the planets to like indoctrinate herself about what order they're in. So maybe they didn't have that song when you were little, or maybe you just put so many other awesome things in your brain that you don't have that song in your brain anymore, or any of those things. We will get there. You will remember them by the end of this unit. But right now, I just want to know what you do know about this solar system. So before we recite all of the planets, can you tell me kind of what the structure of the solar system looks like? So Mariana, get us started with that. Was that your hand still up or no? Okay, so she said yeah, sort of. So this is like not quite the picture, but tell me what you know about the solar system. We know that the sun is in the middle. Okay. What else do we know? Beth, what else do you know? The planets orbit the sun. Planets orbit. What does orbit mean? Yeah, they go around it. Yeah. What can you tell me about their orbits? What kind of shape do they draw while they go around the sun? I've talked to you guys. I want new people. What'd you say, Haley? No. Oh, okay. I thought you had. What shape do they make? An oval. Yeah. So they orbit the sun in. Oval is kind of a funny word. I was actually just having a conversation with a math teacher about this because it's not a really technical term. The technical term for oval, I'm going to say oval path. But I'm going to give you the technical term for oval, the mathematical term. It's actually an ellipse. An ellipse. So have any of you heard ellipse before? Yeah? Okay. So this is the analogy that I used last period that I think made good sense. Every square is a rectangle. Do you agree with me? Yes. But is every rectangle a square? No. So a square is a very specific kind of rectangle. Okay? Every circle is an ellipse, but not every ellipse is a circle. So an ellipse can be a circle, or it can be kind of a squashed circle. And we're actually going to study how big those circles are and what they look like in a couple of days. But I just want to give you that word so that you know it. Okay? So the sun is in the middle and the planets orbit in some sort of funny oval path. And we'll talk about the relative sizes of the planets. We'll talk about the relative distances of the planets another day. Really, all I wanted to do today was just to draw a picture. So at some point here, I'm going to have the sun. You're telling me that's in the middle. Okay? And that's pretty big compared to everything else, right? So there's my sun. Here, maybe I'll make it even a little bit bigger. Wow, it's so big. There's the sun. Going out from the sun, number one is... Isn't it Mercury? It is Mercury. It is Mercury. Mercury is really little. It's a rocky planet, okay? It is small and really hot. Why is it so hot? It's really close to the sun. There's a lot of radiation, right? Lots of photons are hitting it. All right, next after Mercury is, go. Venus. Indeed. Next one, I'm looking for somebody over here. Go. Earth, yeah. Earth is the third rock from the sun, right? The third planet out. And after Earth, I'm looking for more people. I want to share more fun. I know that you've got it. Drew, what you got? Mars. Mars, he says. Yes, it is Mars, for sure. These are the 4 rocky planets. 1, 2, 3, 4. Which one is the closest in size to the Earth?
Venus.
Mars.
Venus. It's Venus.
It is Venus. It is Venus. Venus is the closest in size and in kind of history, we think, to Earth. But when we talk about when people on Earth talk about needing to go to another planet, like if we need to colonize another planet. Do they ever talk about going to Venus?
No, it's too hot.
It's too darn hot there. It is so hot. Why is it so hot? It's closer to the sun. And the second issue, go Drew.
Its atmosphere has a lot of carbon dioxide in it.
It's got a lot of nasty stuff in it. So you guys have heard of the greenhouse effect, maybe, right? That kind of holds energy in. It keeps us warm, and it's good. And if we didn't have it, we would die. Okay, but on Venus, the greenhouse effect is so intense that it's a little hot. It's a little too warm there for us. Okay, so when we think about colonizing a planet, which one are we thinking about mostly? Mars. It's a little further away, so it's going to be a little cooler in terms of the amount of radiation, right? But better to heat ourselves up than to, turn into little crispy people while we're trying to make a colony, right? So yeah, so 1, 2, 3, 4, those are the inner planets. After Mars, there's some asteroids and some stuff like that, and we'll talk about that another time, but not right this moment, okay? After Mars, though, the next planet, Caden, you got it? No? He's like, I don't have it. I saw another hand. I want to share the fun. All right, we're going to go here, and then we'll go to you next. Go. Jupiter! What's so special about Jupiter?
It's the biggest planet, right?
It's huge. Yeah. It's very large. It's not as big as the sun. But it's pretty awesome. It's got storms that have been there for a long time. Although I heard something that some astronomers think that the storm on Jupiter is actually kind of fading out right now, which is kind of awesome and crazy. Thank you so much. You get to sit right across from Jaquette's right over there in the corner. New seats today. New unit, new seats. All right, so there's Jupiter. It's the big one. Right, remember I told you that if Jupiter had been just a little bit larger, it might have had what in its center? Nuclear fusion, and then we would have had how many suns or how many stars? 2, and then we would have had a binary star system. How cool is that? Binary means 2. We'd have had the sun and Jupiter orbiting, and then we would have done like some crazy figure 8 patterns. What? Be awesome. Anyway, there it is. All right. After Jupiter, what comes next?
Is it Saturn?
It is Saturn. Everybody loves Saturn the most. Why does everybody love Saturn the most?
Because it's got the little rings.
It's got the pretty little rings around it, right? Yeah. Now I have a question. Is Saturn the only planet that has rings?
In our solar system.
It is not the only planet in our solar system that has rings. In fact, Saturn and the other 2 planets have rings. Okay? It's just that, well, number 1, Saturn is much easier to see than the others. We'll talk about that in a second. And the rings of Saturn are much more prominent. Okay? But Saturn really does look like that. Okay? And it is the second largest planet as well, which is kind of interesting, and a lot of people don't know that. There's Saturn. What do we got after Saturn? I saw another hand over here. Go. Uranus. Yeah, Uranus is next. Uranus is funny. It's really big. A lot of times I think people think that Jupiter and Saturn are huge, and then Uranus and Neptune are like on the order of us, like our size. Really not so much, okay? Uranus and Neptune are enormous. They are still gas giants. They are big, okay? Uranus is funny because it has rings, but they go up and down like this. That's kind of fun. I know, right? It's kind of weird, but that's what they do. There's Uranus, and then the last one. Everybody say it together.
Neptune.
Oh, yeah. We love Neptune.
Pluto's not a planet.
Pluto is a dwarf planet, yes. Pluto is a dwarf planet. And for our purposes today, we're not going to include it in our list. We'll talk about what dwarf planets mean. We can even have that conversation later. But for right now, we're just going to stop at Neptune. If you want to include Pluto as a dwarf planet on your picture because it makes your heart happy to do that, I'm not going to stop you. I'm not going to come around with an eraser and be like, no! Because really, I don't care that much. If that makes you happy, by all means. Question?
Doesn't Neptune's orbit, doesn't it cross with Pluto?
It does, yes. So there are some funny things that happen out way far. So like our orbit is an ellipse, okay? But it's an ellipse that is just like a little bit squished. So it's pretty much circular, but a little bit squished. But the orbits of Uranus and Neptune are really what they call elongated. They're really long and thin. And one of them, Neptune, I think, is at a funny tilt. And I can't remember how big of a tilt it is, but we'll talk about that later when we actually talk about what's going on. But does this kind of make sense to people? Can we see any of these planets with our naked eye?
No, we can see.
Yeah.
Yes.
Yeah.
How many of the planets do you think you can see with your naked eye?
Saturn is 4.
3.
No, if you're lucky. Jupiter.
If we include Earth,
I am including Earth. Good call, Drew. Because that, yep. Yep, because it's like you can see 4 up in the sky, but if you look down, well, there's one of them. So we can definitely see Earth. Check, everybody's seen that one. Other planets that you can see with your naked eye, you can go out tonight, look up at the sky.
If it's clear.
If it's clear, right? Yeah. Mercury is too close to the sun to see with the naked eye. It's usually really, like literally, it's funny, right? Because, we think of the sun going up and coming down, but really we're just rotating. Is that making sense? Yeah, so we're rotating and the sun but Mercury is always very close to the sun. You can see Mercury with a telescope, but it's hard to see naked eye because it's so close to the sun. So any light that's coming from it is going to be kind of swallowed up in our optics by the sun itself. Venus you can totally see. Venus is one of the planets that you can see on almost a daily basis. If you look, it's called the morning star. If you look just before the sun comes up or just after the sun goes down, so looking in the east just before the sun comes up or in the west just after the sun goes down, it's usually a very, very bright star just above the horizon. Okay, because again, it's following the sun. Are you with me there? Okay, so it's going to be near the sun. So Venus you can often see in just at what they call dusk. Obviously, we can see the Earth. Mars is out there very often. You can see it. Jupiter for sure, and also Saturn. You can see all 5 of those planets. Not every night, because sometimes they're on the other side of the sun, right? But you can see them with fairly good regularity. It's kind of nice at this time of year, even though everybody gets crazy because the days are much shorter and the nights are much longer, okay? Even though that does happen, the nice thing about that is that you can see up at the sky and you can see the stars earlier at night. So like you leave practice, you leave work, you're out when it's a little dark. Before all of the stars are visible, you can often see a few bright stars, but the stars that you see are really Mars, Jupiter, and Saturn often, okay? So take a look up there, okay? If you want to get really technical and excited, there are some really nice apps for your phone. If you just look up star chart, okay? The app that I love and that my kids love a lot, you just turn it on and then you turn it's on. It's connected with GPS. You just point it in that direction of the sky and it tells you exactly what's there. It's pretty awesome. It puts the constellations up there for you so you can see them, which is awesome. And then you can be like, oh, what's that? Oh, what's that? And so like, yeah, so you can figure out some of the names, like those names that we've talked about, like Betelgeuse and Altair, and there's some other really bright stars that you can see. Okay, but you can also, it'll tell you where Jupiter is and where Saturn is and that kind of thing, which is kind of neat. So anyway, there you go. A little hint for the day. Questions about this? Yeah, go.
I just have a question of how we know that Uranus and Neptune and Mercury are there, but we don't really know because we can't see them. So it's you can see through a telescope, how we know it's there.
Yeah, so we can't see them naked eye, right? And we're it's as if I planted that question with you. Thank you so much for asking. So what we're gonna do in the next few days here is that we're going to look at the history of our understanding of our solar system, okay? And for a long time, we really only thought that we had Venus, Mars, Jupiter, and Saturn. That's all we knew about, right? Because we didn't know Mercury was there because we didn't see it. And same with those guys. So before the advent of the telescope, before the telescope had been invented, they may know who invented the telescope? Galileo. Yeah, Galileo invented the telescope or figured out how to use the telescope, really. He wasn't the person that set it up, and he's like, hey, that thing that you're using to look out at ships, I could look up and then I can see stuff in the sky, which is pretty awesome. Before that, we just thought it was this. Now that we have telescopes, and the better the telescopes get, the better we can see stuff. Does that make sense? So you can go to an observatory, like a public observatory now, and you can see Uranus and Neptune with a telescope. They're bright enough that you can see them. Does that make sense? So it's just technology that gets us where we need to go. Yeah. Other questions before we move on? So to kind of answer Haley's question, we are going to do a little learning about the historical perspective. So I'm going to hand a sheet to you, and I'm going to propose that instead of making you do research on all of these people, we share the effort, we share the challenge, and we will use our collective brain to work at this a little harder. Thank you. 1, 2, 3, 4. Sorry, that always like I have to say that one. Back there. 1, 2, 3. All right. Today we are going to focus on the front of this sheet. So, throughout history, people have been looking at the stars, like that's a thing, right? We've always been trying to figure stuff out. And there are some key names of people who have not only looked up at the stars, but actually like tried to figure it out and like articulate it a little bit more. So on the front, there are 4 of them, and we're going to look at them in a minute. We need to figure out when they were alive, when they were working, because that's going to be that's going to help us put things together. The other 2 columns, one says, draw a picture that represents the astronomer's claim. Okay? Where was the Earth's location in relation to the sun and other planets in the solar system? The funny thing is, ladies and gentlemen, that this view of the solar system is not where we thought it was, right? You know that because we learned about, what's his name? What was his name? Bruno, right? We talked about Bruno, and Bruno was a person who was like, Earth's not in the center, yo, right? So that's where we're going. We're taking steps towards that now, okay? So you're going to find out some claims. The claim is in the form of a picture, so you might want to circle or highlight. Woo, that was fun. The word picture. That's what's going to go in that column. And then the evidence, this is the big deal as a scientist, okay? Anybody, not making any political statements, but anybody can make any claim that they want to, right? Anybody can say whatever is true, but the only reason that I'm going to believe you if you make some sort of radical claim about the world or about anything is if you have evidence, if you have made observations or have data to back up your claim, okay? So this is what I really want to know. Thanks so much. What I really want to know is, what did the astronomer do or see or observe to give them evidence to support their claim? Okay, so that's what we're going to do today. We're going to figure that out. Not everybody is going to do all of them because that sounds like a lot of work.